My name is Annett Bartsch, and I'm originally from Germany, and I'm a geographer. And I started to work in the Arctic already in the late 90s, first in Finland, then in Sweden and Norway. And then I obtained my PhD actually from a university in the UK, from the University of Reading in 2004. And that was in periglacial geomorphology. So I was working at that time on field sites in Norway and in northern Sweden. And I've always been working with satellite data. I've been specifically interested in radar data. So with radar, we can see different things than with the optical data, or different things that we can see with the eye. And you can look with that of clouds, and you can also make observations during the polar night, what is really important when you work in the Arctic. And you can observe things like changes in snow, and for example, changes in snow structures. So when you have these rain on snow events, where ice crusts developing, which are have an impact on reindeer. And so this is something that you can identify with radar data. And that's also something what I've been working on in the past, also together with Bruce Forbes and Timo Kumpola. Well, we have been working together, with Timo, I've been working together also on reindeer pastures, conditions of plants, different types, winter and summer pastures already back in the 90s. But the recent years I've been focusing on the use of radar data. People have been looking on melting snow, thawing and refreezing already. I think some papers started to appear in the 90s with the early scatterometers, the ERS-1, the European Resource Satellite #1, which was launched in the beginning of the 90s. There have been already passive microwave instruments, radiometers, which date back to earlier times. And there are data sets available from the US, actually originally for military purposes. Mm-hmm. So people have been looking into this melting of snow. And already started in the 90s to look into snow properties. So the amount of snow water equivalent. But to look into rain on snow with that started then only, something between 2000 and 2010, or towards 2010, so about 10 years ago. Yeah. That's when people started to look into that related to Arctic issues. There was first a paper on muskox. There was an island in the Canadian Arctic where an entire population of muskox was wiped out because of a rain on snow event. And at that time, the American colleagues or Canadian colleagues have been using passive microwave data radiometers to prove this, because nobody was there on this island when it happened. Mm-hmm. And then, at some, I think it was 2008, something like that. So I was working on melting snow, because that people have been working on that for a while. So freezing, thawing in spring, how long is the spring snow melt season? Because there's this big discussion on, is the snow melting earlier now with climate change? So those were the issues that we have been looking into. And now these algorithms, there's always a bit of a problem when you had some melt events earlier happening than spring. It's kind of anomalies, disturbances, so that people try to somehow delete from or get rid of that. And then I met for some meeting Bruce and Timo, and we talked about that, and they just had this, there were these recent observations actually from Florian Stammler on this event on the Yamal Peninsula, where he was traveling with the Annetts in this region, and he observed this ice crust there. And when I saw these reports, and I told them, well, yeah, we can see this in the satellite data, of course. This is coming up very clear. Mm-hmm. So we were sitting down and thinking up how to bring this together, these observations from Florian. And a year later, we had a paper out on that, and with a method which can be applied for the entire Arctic. And later on, I ran that for the entire Arctic to identify these events, so spatially, and how often they happen. So we now have a good idea about how frequent they are in certain areas.
I see.
But this is a very coarse spatial resolution. So we are talking about several tenths of kilometers. And of course, these events are really widespread, so that's why it's applicable. But there are also, now we have these new satellites like the Copernicus missions, and one of them is a radar instrument, which is a SAR, a synthetic aperture radar, which has very high spatial resolution, in 10 meter actually.
Wow.
And it's not as frequent as the other satellites. So the advantage of these coarse resolution satellites is that we have a high temporal resolution, high revisit intervals. But there are already 2 of these SAR satellites in orbit. So if you have several, this also makes the revisit intervals better. Mm. And all these missions, they are what we call polar orbiting. So they are almost moving north-south. And so what in the end, we have lots of overlapping orbits in the Arctic. So the further north you get, the more overlap you have. So you have denser records. Mm-hmm. It's just a lot of data processing. But with 10 meters, you can maybe imagine that's a huge amount of data. And this is something what we have the data for, and what we now can look into, so we can get much more precise information on these rain on snow events. So this is also one thing that we are going to look into in the project. You need a kind of a system how you organize your data in a database specific grid, where you then every image that you get in gets assigned into this grid, into these tiles, into this database. Then you need to apply some corrections on each of them. So that's really the most time consuming, to bring them into a format which makes them comparable with other data. Yeah, that you have a precise geolocation for each point, that you can then bring it together with other observations from related to reindeer herding or whatever settlements, that you can somehow combine that, and that you have a really good also time series in that. So, and once you have that, once you have a well-organized database, then you can extract time series out of that for each point, and derive, or develop specific algorithms to retrieve the information. Well, so far we have been using some standard time series analysis. What is now more and more of interest are these approaches for artificial intelligence. This is something what we have been using in other projects before, what we are currently also using in, as for example, this Horizon 2020 project Nunatajok, which focuses on permafrost thaw in coastal regions and the impact on local communities. And here we are using that to identify coastal communities, to identify settlements, roads, so human impacted areas, combining radar data with optical data, and that's actually only possible using artificial intelligence. So that's a really helpful way to work with the data. You have quite a diversity of information, of input data, and quite a diversity of patterns on the ground, on the way things, the different attributes, a certain, or properties, a certain surface feature element can have. And that's not only over time or at a certain point in time, it's also spatially. So we then talk about texture or objects. So each feature on the ground has a certain texture, it has certain properties in the surrounding. And these algorithms, they are able to bring this together. So the traditional information that we get from remote sensing, like that's the amount of reflectance at a certain wavelength. And it brings that together with the spatial properties of that object. And then it starts to get really complex. And these algorithms, there is quite a diversity, but they test, they follow different routes. Often we talk about trees in an algorithm. They follow these trees, these decision rules in parallel or in a sequence, depending on what statistics are used, to come up with best possible approximation or a best possible result. So you have some targets, some ideal output that you want to have in an area that you know well. And so these algorithms, they allow to find the right processing chain. Let's put it like that. The images are available within a few hours nowadays. So that's quite fast. And then you need several hours. It depends on the algorithm, several hours to pre-process that. So you could have, if you have the algorithm ready, you have it identified, and then it's a matter of a few hours to come up with a result. But first you need to come to this algorithm, which is quite demanding. And then the question is, so what is the area that you're looking at? So if it's more than one image that you want to process, and then that of course takes time. And what is here also of relevance is the download, the speed of the download. It's huge data sets, so it's always gigabytes that you need to download. That takes time. So it depends on your internet connection. And then what you usually do nowadays, you do cloud computing. So you're not processing it on your own machine. You process it somewhere in the cloud. Well, BGEOS is a small company, an SME, which I founded 3 years ago. And we focus on largely supporting scientific projects in utilization of satellite data, and mostly researchers which focus on the Arctic. So actually BGEOS is a member of the Austrian Polar Research Institute due to our focus. So we develop kind of services also for the European Space Agency. We support that specifically related to permafrost monitoring. And then there is this example of the Horizon 2020 project Nunatayuk, where we support the project with this data processing of images coming from this new Copernicus missions. And then that's also exactly what we will do for the Charter project, where we will, so in one hand, we will do some processing at BGEOS. And then another task is, or my task is, to do a bit of coordination of one work package. So that's the work package 1, where we focus on the utilization of satellite data. We will, with many partners, actually there are 15 of the 21 partners in Charter are involved in work package 1. And that's reflecting the amount or the different diversity of information that we can get from satellite data. That's why we need these different partners, and it's also reflecting the importance of satellite data for this type of investigations. And so what we will look at with these partners, it's not only snow on land, but also vegetation properties, sea ice. So that's quite a diversity. We look at things which can have an impact on diversity, but also which give us information about diversity, which are proxies for diversity. So like vegetation health or heterogeneity of the land surface. Specifically, we can look into the changes on the ground related to disturbances. There are disturbances by humans, of course, but there are also natural disturbances. We have in the Arctic with permafrost thaw, which then results in, for example, drainage of lakes. So we have a change here from water to vegetation, maybe a change into a pasture. And we have there, what we see a lot are these so-called thaw slumps, which is a type of landslide. And then locally we have a change in vegetation communities, and these changes, they are visible over hundreds of years. So this is quite an impact here. So we can observe changes in habitat properties, and we can look into what is driving these changes by looking at snow, looking at sea ice. And what we want actually in work package 1 is to understand what the drivers of these changes in biodiversity are. And then this information can be then, together with the in situ observations and the community observations, that can be then used to model what is going to happen in the future. And then based on that, this to develop options for policy. We will build up a kind of database. Mm-hmm. So these partners will contribute to this database, and what I will coordinate. And in some cases, I will work directly with some partners on developing some parts of the database. So where we bring radar data, for example, together with some other observations. We have partners doing UAV, this unmanned aerial vehicles observations at certain sites. And we somehow need to connect that to the satellite observations. And then we also have representatives from the other work packages in our work package. For example, for the in situ observations, it's really crucial to have these in situ observations when you look at satellite data. Mm. So we need this link. But we have kind of, depending on what people are looking at, kind of subgroups also in work package 1. So sea ice is a certain group. And then vegetation observations is a certain group. Snow, also we have one group where we look specifically at snow. That's BGEOS as well as the FMI, which is also involved in the project. So they do some in situ observations as well in Finland, in northern Finland, what we can make use of in the project. That you can't get that for everything. That's the point. And the further you get back in time, the coarser is your spatial resolution, or the smaller if you have a higher spatial resolution, it's only a tiny area that you can cover. Now, I was already mentioning this passive microwave observations from this US satellites, where people have been looking into snow properties in the past. And those are the type of sensors that we can use to go back that far, back in time. They are a coarse spatial resolution, but they're used usually for sea ice observations. They can be used to look at general snow properties. And then there are some also for records that we have for vegetation change. That's in the order of 1 kilometer. But it gives us a general picture about surface change. But the actual detail, when we want to have some detailed observations, in that case, we cannot go far very back in time. But for some of the parameters of interest, we are able to do that. Because the satellites are still taking the observations. But you need these in situ observations. Well, there are some available from the past, but specifically if you think about biodiversity in the Arctic, there are many gaps. So we need additional observations. And some of them have been supposed to happen this summer for charter. And also these UAV observations, and specifically in Russia. And there will be no way doing that this year in Russia. So we will not have them. So that will only start in next summer, hopefully. Maybe there's some replacement or some observations they can be made in Scandinavia, specifically in Finland. So specifically the Finnish partners are planning that. But there is some delay with respect to these in situ data collections. We can start to work building on past observations, but the actual validation and in some cases calibration, we can only start doing that next year. We hope that we can do that next year. What we try to do is to understand these drivers of changes on the surface in biodiversity. And of course, also then how these changes in biodiversity affect people, or how people have an impact on the biodiversity. And once we have this understanding of these interrelationships, then we can come up with some kind of projection or some idea about what is maybe going to happen in the future with employing models or climate projections. And then based on that, we can provide information for decision makers. So, and this is what I see as the output of the project. What we need to know is what is driving that. And there has been some work on that. Actually, Bruce Forbes has been working on that in the past. And together with the sea ice researchers, he has been looking into, is there a relationship between that, or somehow do we see any anomalies here which relate to these rain and snow events? And they actually found that. So that specifically when in late autumn, when there is the ocean is ice-free for a bit longer than usually, this leads to certain weather situations, which then lead to these rain and snow events. And this is the reason why we are looking into this diversity of data sets. It's the reason why we are looking not just on land into the snow properties, that's why we are also looking at sea ice data. Because there has been this indication, or there have been several cases described where we had this where there seemed to be this relationship of sea ice conditions, which we know that they are changing right now with climate change, and then the occurrence of rain and snow. And this understanding, or a precise understanding of this helps us then to kind of predict, or then we know this is when the sea ice developing in that way in that specific part of the Arctic, that then can lead to these really severe type of weather situations. So it's about bringing different types of data from around the Arctic together, which help us to understand these consequences, which are then impacting people. Already in school, I was interested in the Arctic. When I read every book that I could find in our library about the Arctic, also Antarctic, and all these explorations. And I was always fascinated about the Arctic. And when I finished school, the first thing I went with Interrail to Scandinavia. And and then also during my studies, I always try to find topics close to related to cold regions. I had the chance to go to Svalbard when I was studying, and then we had to do some internships somewhere, could be somewhere in the world, and I've chosen a trainee or a position in northern Finland. So I was working at the reindeer research station in Karmanen, then also met Timo Kumpula.
Yeah.
Was working exactly on this topic for his master thesis. And then when I finished my master, I looked around what next to do, and I saw this PhD studentship kind of PhD program in the UK. They had in the 60s they had built a research hut in northern Norway. Oh. And above the tree line. So nowadays it's really problematic to have something above the tree line, and they had to show that they use it for like research purposes, and every few years they announced a PhD scholarship that someone is doing some research there. Before I had been doing some work close to Abisko. During my PhD, I combined observations from near Abisko, the Kærkevakker, close to the Norwegian border, with this other setting from near Oxtinden, looking at periglacial features, solifluctions and rock falls, and how you actually can identify them with satellite data. So at that time, that was, well, nowadays that's quite common to do, but at that time it was quite new. One problem was also that you had to pay for data. Nowadays you have so many such satellite data for free, and at that time we were happy about just one image.